Okay, you guys, this is Hess's Law, Chapter 5, Section 6. Make sure you go to Google Docs and get out your class notes so that you can contribute to those, okay? So here we go. Enthalpy is a state function. State as in solid, liquid, gas, okay? Whenever you change from one state to another, you have to include that enthalpy in the total of the reaction. So we're going to look at the combustion of methane. You know that whenever you have a combustion reaction, you have oxygen involved. And methane is CH4 plus our oxygen. And we get CO2 plus water. Now, look what I have here. I have liquid water up here. I have gas water down here. That is not a typo. When we actually start out this equation, we get gas. We do not get liquid. So we need to balance this. And this has an enthalpy of a negative 802 kilojoules. Now, we have to go, like I said, from the gas phase of water to the liquid phase of water. So we write another reaction for that. H2O gas goes to H2O, and it's 2H2O. Liquid. We keep the 2's because that's what it was in the original equation. And this has a delta H, because it is a state function, enthalpy, of negative 88 kilojoules. Now, to figure out the enthalpy for the total reaction, we just do a big addition problem, okay? So here we go. We are going to put our reactants on the reactant side of the arrow and our products on the product side of the arrow. So here's our first reactant, CH4 plus 2O2 plus 2H2O. Oh, that's a gas. Don't forget that. Then our product side, CO2 gas plus 2H2O gas plus 2H2O liquid. And because we added together our reactions, we are also going to add together our enthalpies. So we have a delta H here of a negative 890 kilojoules. Now, it seems like we should be all done, but we've got some kind of redundancy in this. You'll notice if you look that we have 2H2O gas over on the reactant side and 2H2O gas over on the product side. And just like in math, if you have two things on opposite sides of the equation, you can get rid of them. And then our delta H is still negative 890 kilojoules. So there is our full equation for the combustion of methane. Now, in part 2, we're going to finish up Hess's Law. Okay? So get ready to do part 2, and we'll be right back.